illustrating a common phenomenon known as hormesis, whereby substances that are toxic to animals in large doses can have favorable or agreeable effects in small ones. Hormesis is widespread in nature, and although scientists still debate how it works, one idea is that low levels of many toxins activate physiological repair mechanisms in the body that have broader effects than simply responding to the toxin. Another suggestion is that toxins in low concentration may promote antioxidant effects in the body. Whatever the case, alcohol does seem to have certain favorable effects on humans when taken in moderation, as attested by a substantial literature on the health benefits of drinking wine. Despite such intriguing discoveries, though, how widely any health benefits of alcohol consumption are enjoyed in the animal world is not known. It is clear that some mammals simply like the stuff, which is hardly surprising because elevated blood alcohol levels appear to enhance the production of epinephrine, or adrenaline, a hormone that acts in the brain to reduce inhibitions. Thus, elephants in parts of southern Africa have long been famous for excessively indulging in the naturally fermenting fruit of the amarula tree, weaving away rather unsteadily after each episode. But as with most other mammals that occasionally go in for such overripe fruit while it is still on or around the tree, this is a strictly seasonal predilection for elephants, limited to the short periods of the year during which the alcoholic fruit is available. Heavy drinking is hardly a way of life for them. More remarkable, then, is the case of the tiny pen-tailed tree shrews of Malaysia. They are particularly instructive in a consideration of why human beings like alcohol, because they are widely reckoned to be among the closest living relatives of the primates, the zoological group to which our species Homo sapiens belongs. They may not be precisely the same as our ancient ancestors from the beginning of the age of mammals some 65 million years ago, but in appearance, body size, and general habits, they probably come close. In 2008, German researchers reported the results of an ecological study of pen-tailed tree shrews in a western Malaysian rainforest. They noted that the little creatures under 50 grams in weight returned repeatedly to feed on the large flowers of the trunkless Bertam palm, an abundant plant of the forest floor. Throughout the year, for prolonged periods of time, these flowers exude nectar to attract pollinators. Frothing and bubbling, along with brewery-like odors, indicate that the nectar is colonized by natural yeasts and begins to ferment virtually as soon as it is produced. The resulting alcohol concentration in the nectar is as high as 3.8%, about as strong as most of the beer traditionally sold in the United States. During the course of the study, several species of mammal visited the Bertam palms each night in search of this resource, including our primate relative, the slow loris. But the pen-tailed tree shrew beat them all in its enthusiasm for the nectar, sometimes spending well over 2 hours per night binging on this delicacy. Oddest of all, the tiny creatures never seemed to get drunk, even when, relative to their body size, they had imbibed enough to cause a large man to pass out from inebriation. Elevated alcohol levels were detectable in the tree shrew's blood, but the tiny mammals showed no physiological impairment. Fortunately, since these vulnerable creatures are under constant threat of predation. Their senses have to be keenly attuned to danger at all times, and their reactions have to be swift. It is clear, purely from the time spent feeding, that the palm nectar is an important nutritional resource for the tree shrews at the Malaysian study site. As indeed beer, which is actually more nutritious than bread, can sometimes be for humans. But if the tiny quaffers had lacked appropriate mechanisms for counteracting the physiological effects that alcohol has in us, they would have been in deep trouble. The example of the tree shrews suggests, at the least, that from the beginning of primate history, there may have been both an occasional predilection for the products of fermentation and a mechanism for processing alcohol. Humans exhibit this primate heritage in their physiology. By some reckonings, about 1/10 of the human liver's processing capacity is slanted toward breaking down alcohol via production of such enzymes as alcohol dehydrogenases. Scientists often marvel at this huge, apparent dedication of resources to one specialized